Welcome to Algebra 2. This is the unit on polynomial graphing, and we just want to look at some real similarities here. Today we're looking at even and odd functions, actually, the graphs of even and odd. So the first thing that they want us to investigate is a graph of x squared, x to the fourth, and x to the sixth. So they have us plug this into a graphing calculator, and they say go to the window and set it to these parameters, which I've already done. And then they want us to go to the y equals window, and we're going to plot these. So we want to go delete on that one. So that's just the x squared. Well, I guess I could raise it to the second. Okay, we can just do it that way. Raise to the second, raise to the fourth, and raise to the sixth. So the first one that it draws will be x squared, second one will be x to the fourth, third one will be x to the sixth. Let's see how that looks on the graph. So there's the x squared. A little bit wider is the x to the fourth. And just slightly wider is x to the sixth. So you can see how it comes down right here. Go ahead and sketch this into your graph right here, all three graphs. Okay, so go ahead and sketch those, rewind if you need to see how they come in on each one. These are my grid lines right here, those little knobs there on the x-axis. Okay, it says, I'll just leave this set there, and I'll read off of another sheet. Sorry for moving it. Okay, so it says on D, use your graphs to identify the zeros of the functions. The zeros means where does it touch the x-axis. They all touch the x-axis at x equals 0. Identify the minimum value for each function. The minimum is how low on the y-axis it goes, and all of them go down to 0. Describe any symmetry of the graphs that there seems to be. And if you notice here, going from one side of the y-axis to the other side is a complete reflection. So they do seem to have a reflection symmetry over the y-axis. Down on the reflect questions, what do all the functions and their graphs have in common? Well, they all have zeros at x equals 0. They all have a minimum value at y equals 0. Y is equal to or greater than 0. And they all have this reflection symmetry over the y-axis, or you could say that their axis of symmetry is the y-axis. For these functions, this is 1b, for these functions, what happens to the values of f of x as x increases without bound? Well, let's go to our graph. This, from the origin over to the right, is x increasing without bound. And they're simply asking, what's happening to the graph? As we go this way, what's happening? It seems to rise without bound. The graph seems to increase. So f of x is going to infinity as x is going to infinity. And it increases without bound. Now on 1c, it asks going the other way. When we turn around, we go x towards negative infinity. It decreases without bound. What happens to the display on the graph? Well, it continues to increase without bound. So when x goes to negative infinity, f of x continues to go to positive infinity. So both directions, the f of x goes to positive infinity. Okay. Now the next thing that they want us to investigate, so those were the evens, 2, 4, and 6. And now they have us go back to the window on the next page, and they have us plot the odds, 1, 3, and 5. Now, I wouldn't have to necessarily put a 1 in, but I like to just so that you see it is to the first power, but x itself also is to the first power. We don't have to put the 1. So these are our odd functions. Again, it'll graph them in the order that I gave. We've got the window set as they ask on the front page. And we need to go down to a different setting on our window to see the bottom part of that. Oh, I see. On their y minimum, they recommend a -5, and their y maximum at a +5. Okay, now we'll go to the graph. So there's the x to the first, there's x to the third, and x to the fifth. Okay, so the x to the fifth comes slightly up a little bit straighter this way. X to the third is the closest one to this diagonal line. Okay, on D it says use your graphs to identify the zeros of the function. They all seem to cross right through the zero, right through there. Identify any maximum values or minimum values of each function. As you notice, all of these decrease without bound and increase without bound on the f of x. So there is no maximum or minimum in an odd function. However, you can at times get a large loop in here and have a relative maximum if it comes up like this, or a relative minimum if it comes down like that. And relative just means within the graph, not all points of the graph, but within that area. None of these have a relative min or max. Describe any symmetry of the graphs. Well, do you notice that if we took and put a pin right here and spun these graphs around, that they would land right upon these? If you just did a rotation of them, kind of like a pinwheel like you used to blow on in the wind, has that rotational symmetry. So it's a rotational symmetry about the origin. And you should also put that it's 180 degrees, because 90 would take it from here to there, and 180 will take it up to there, straight across. So what do all the functions in their graphs have in common? You can just relist what we did in D, E, and F. Then it says what points lie on all the graphs. Interesting enough, if we trace, 0, 0 lies on all the graphs, and -1, -1 lies on all the graphs. And right up here, at +1, +1 lies on all the graphs. Okay. For these functions, what happens as x increases without bound going this way? Well, the y increases without bound going up, just like it did on the even function. However, it's quite different when we head towards the negative infinity. For 2D, it's asking what happens as x goes towards negative infinity without bound. The graph appears to go down, so it goes towards negative infinity as well. Okay. When you're using these in class, would you please make sure, anytime you use one, when you're all done, to hit the second on, and that'll turn off the calculator. That will really save us some money in our department on batteries and helps you guys to get more stuff. Okay, next up, describing characteristics of the functions. Okay, all that we're looking at here are again these end behaviors. An end behavior is what's happening at the end of the graph. The end behavior of a function is a description of the values of the function as x increases without bound or decreases without bound. And it's exactly what we said is happening on the odd functions. Now we're just grouping all the x1, x3, and x5 together. They all have this general same type of a situation here. And evens are x squared, x to the fourth, x to the sixth, and these could go on in that pattern. Both of them could. Now what you'll notice with the even function is that for all values of x, that you will always be able to find an x, y, and it's symmetric over the y-axis. So you will find that same value of y with a negative x. Now that's when it's an f of x. Now in an odd function, what you'll find is you'll find a value of x and y, and you'll find a negative x and a negative y. The reason I share that with you is because tomorrow when you come into class, I'm going to post some t-charts and ask you, is this an odd function or an even function? You want to look for that relationship and be able to say, oh, it's even because of this, odd because of that. So make sure you understand that correlation. We will be talking about it in class tomorrow. Okay, for the function g of x, you are told that g is 1,000. G of 1,000 equals 5 million. Is it possible to make any conclusions about the end behavior of g of x? Well, we're given one point. That point could be right here. In fact, they're both positive, so it's somewhere in this first quadrant. But do you notice how both graphs exist in that first quadrant? So we really can't say anything about end behavior when given only one specific point. What can you say about the end behavior of x to the n when n is even? Okay, so again, be able to restate what's happening on the end behavior just like you did on 1b and 1c on page 1. And 3c asks, what can you say about the end behavior when a function is odd? You explained that on page 2 on 2c and 2d. So if you don't remember, go back and read through them and think about what we said there. Maybe even rewind the video. Okay, explain why any function in the form x to the n is an even function if n is even. So you need to explain how come we end up with the situation that x results in y and negative x results in y. Please explain how we eliminate the negative form there, which causes the symmetrical axis on the y-axis. Okay, and then on the odd function, they're asking, why is it odd? So again, explain why this occurs. When we plug in a positive, we get a positive. And when we plug in a negative, we get a negative. And explain how that creates this basic shape. Okay? When you come into class tomorrow, we're going to have several warm-up problems, and then we'll complete this graph together. Have a great night.